I'm taping a lesson on inverse functions today, just in case we have a cyber day, so that you guys can keep on track. So your goal is to go through this, come up with some questions that you may have. If you're not understanding what I'm talking about, just play it again, that portion again. Maybe even look up some things on the internet. But we definitely, when we return to class, we definitely will go over it, but I do want you to have an idea of what we're talking about. So we're talking about inverse functions, and I know most of you haven't heard of that before, so it's going to be a little bit new. So just try to bear with me at the beginning. So an inverse function, it actually interchanges the input, which is our x values, input, which is x values, and our output, which is the y values of the original relation. And a relation in this case is just a function such as f of x is equal to 2x plus 4. So knowing this, so it interchanges the two. So what it does is it switches the two values. So the domain of the inverse is the range of the original relation. And the range of the inverse is the domain of the original relation. And we will look at some charts and tables in a second that will help you understand that a little bit more. So the first thing that we need to do is we have a function here. And my first step is I can always rewrite the function with x, substituting f of x is equal to y. So rewrite the function, and I'm going to say function is fxn, where y is equal to f of x. So we're going to kind of talk about those two things interchangeably. The next step is you're going to switch your x and your y value, because remember the inverse, it interchanges your x and your y's. So you're actually going to switch your x and your y in your equation. So what that means is, so the first thing I did was I rewrote it to see y is equal to 2x plus 4. And then I'm going to switch my x and my y. So instead of y, it's going to be x is equal to 2y plus 4. And then my third step is I'm going to use my math algebra skills to resolve for y. So resolve for y. So you're basically telling me what y is equal to now. So let's look at that particular problem. So I'm resolving for y. So I'm trying to get y by itself. So I'm going to subtract 4 from both sides. So it becomes x minus 4 is equal to 2y. And then I need to divide both sides by 2. And so then I come up with the equation of y is equal to x minus 4 divided by 2, and then I'm going to rewrite this in a linear form, meaning I'm going to take y is equal to x over 2 minus 4 over 2. And then you can simplify, and that becomes y is equal to 1/2 x minus 2. And you understand kind of what I'm saying there now. But notice it's not actually my y anymore. It's the inverse of y. And so you have to put a little -1 up above, like in the subscript spot of the y, to denote that it's inverse. So the inverse is looking for a way to take us from the range back to the domain. So notation of f to the -1 of x or y to the -1. So the inverse of a function is denoted by f to the -1 of x or y to the -1. So you have to ask yourself a question. You're going to be given functions. You're going to have to tell me how can you tell if an equation is a function, and you're going to be able to tell graphically and numerically by a table. So graphically, that's what we're going to cover first. A function is called one-to-one if no two x values produce the same y value. In order for a function to have an inverse function, it has to be one-to-one. So basically, it has to be the situation where it is a one-to-one. So no x value has the same, or no two x values have the same y value. And then if the inverse is not a function, we call it inverse relation. For a function to be one-to-one, it must pass the vertical and horizontal line test. So we're going to talk about the vertical and the horizontal line test. So it says, what does the vertical line test tell you? And the vertical line test tells you if the function, or if the relation is a function. And if we do a horizontal line test, so a vertical line test would be I draw a vertical line and I make sure it only touches the graph one time at every single point on the graph. Okay, the horizontal line test tells me, it states if the inverse relation is a function. So it tells you if the inverse, so I'm going to put that in capitals, inverse relation is a function. Okay, so an example of a function that is not one-to-one is f of x is equal to x squared. So let's talk about this. If I have this function and I plug in 2 for that, f of 2 into x squared would be 4. And then f of negative 2 would also be 4. So I have an x value that, or I have a y value that gives me 2 x values. So f of x is equal to x squared passes the vertical line test. So it does pass the vertical line test. If you look at the graph, it only gives me one output for every x. So it is a function. However, it does not pass the horizontal line test. So it is not one-to-one. Okay, so this is kind of the big thing here. Everything you need to know. If it passes the vertical line test, it is a function. The relation is a function. If it passes the horizontal line test also, it's one-to-one. But if it doesn't, such as this graph, then it's not one-to-one. And we're going to do some examples. So flip the page to page 12. So example 1 here, I need to make sure that you can see this on the camera. Example 1, it says determine if each graph is a function. So I'm going to determine that, I'm going to use the vertical line test. So basically, I'm going to take my pen and it's only going to hit the graph at one point for every vertical line. So this actually does pass the vertical line test. So yes, it is a function. Okay, so the relation is a function. And then I'm going to see, does it pass the horizontal line test? And so it does pass the horizontal line test. So yes, the inverse is a function. And then because both of the answers are yes, because it is the relation is a function and the inverse relation is a function, then it is a one-to-one. So yes, one-to-one. That means for every x I have one y, for every y I only have one x. So then we look at this one and I do a vertical line test. So, and it passes. So yes, the relation is a function. But when I do the horizontal line test, such as the dotted line that's drawn here, this horizontal line, it hits the graph 3 times. So for that y value, it has 3 different x values. So no, the inverse is not a function. Not a function. And then we go, and it is not one-to-one because the answers are both not yes. If you look at example 3, or example C, excuse me, it does not pass the vertical line test. So it is not a function. The relation is not a function. Okay, but the inverse is a function. Okay, and then it's not one-to-one because the answer is not yes. So this one was no, this is yes. So not one-to-one. And then it says, how can you tell a relation is a function from a table? And so this is what I was talking about. So we're going from looking at it graphically to looking at a table. And so numerically, to be a function, the x values cannot repeat. Okay, so the x values cannot repeat. And basically what this means is for every x value, there is only one y. Okay, and then how can you tell if an inverse relation is a function? And this is, you can tell by the y values cannot repeat. So in this case, for every y value, there is only one x. Okay, so if I am looking at a table and I'm trying to determine if it is a function, the relation is a function, I have to see in this table, do I ever have an x value that repeats? And so in this case, the relation is a function, so yes, a function. Then I have to look and see, do any of the y values repeat? Okay, and so here, if there's no y values that repeat, the inverse is a function. And the same thing applies here. So because both of the answers are yes, it is a one-to-one relation. Okay, and the same goes for B. No x values repeat, so yes, a function. Looking at the y values, no y values repeat, so yes, inverse is a function. And so again, it is one-to-one. Okay, so that's using a table. Then looking at the graphs, it says, what do you notice about the graph of f of x and its inverse? So this is my graph of f of x, and this is my graph of its inverse. And you can see, here is my f of x, and here is my inverse. And here is the line y is equal to x. Okay, this is a line, y-intercept is 0, slope is 1. And it says the graph of the inverse is a reflection of the actual function about the line y is equal to x. And this is the equivalent of switching all the x and the y values. So if you think about when we were studying in Unit 1 transformations, when we were studying reflection, and how when we flipped it over the line y is equal to x, we just switched the x and the y values. So moving on along to page 13. We'll do a few here, and then I'll let you do some on your own. Okay, so when the relation is also a function, you can write the inverse of the function f of x as f to the negative 1 of x. This notation does not indicate a reciprocal, so do not forget that. This means inverse, not a reciprocal. So the functions that can undo each other are inverse functions. So what it says, if I have an input of 3 into the function, an output of 9, its inverse, if I have an input of 9, the output will be 3. So it says find the inverse of a relation from a table. So basically all I do at this point is I'm rewriting the table, and where all of my y's, I put them as x's. So 0, 1, 2, 3, and 5. And then all of my x's become my y's. 1, 3, 4, 5, and 6. And that's all you do. It's that easy. I've just switched my x's and my y's. Okay, and the same thing applies here. Okay, so where all my x values will become my old y values, 1, 2, 4, and 8. And then all my y values will become my old x values, 1, 2, 3, and 4. Okay, so then we have some problems that we're going to work out. And you can do these on your own, and I'll do A with you. But you can do kind of the next page 13 and 14 on your own. So it says find the inverse. So the first step, recalling from the very beginning, is I rewrite it as y is equal to 2x plus 4. And I think this is the actual problem that we did at the very beginning. The next step is I switch my x's and my y's, and then I resolve for my y. So I'm going to finish that up here. It becomes x minus 4 is equal to 2y, and then I'm going to divide each term by 2, so it becomes 1/2 x minus 2 is equal to y. This one is the same as my example from the very beginning. So this would be my inverse function, and do not forget to put y to the negative 1. Or we could rewrite it y to the negative 1 is equal to 1/2 x minus 2. So hopefully that will help you do this. Now remember, when you get down here to F, that you need to make sure that first, so in this case, I would rewrite it, x plus 2, and then I have to switch my x's and my y's. So at this point, I would say x is equal to 2y plus 2, and then I have to divide both sides by 2, and then is equal to the square root of y plus 2, and then to get rid of the square root, I have to square both sides, and then I have to subtract 2. So I'll let you do the rest of it on your own. But 13 and 14 are yours for homework. Good luck.